any force you take in the nature, so that can be written in the form of mass into acceleration. Right? F is equal to ma, which is the final expression from Newton's second law of motion. Right? Isn't it? So this is the concept of Newton's third law of motion. And let's discuss some more analysis related to the Newton's third law of motion. Right? I just wanted to give you the real life, a simple scenario and or the example related to the third law of motion. Right? So imagine, so this is what the hand I have. Okay? I'm just closing all the fingers in this way, so I can make my hand to punch somebody or to punch something, right? Look at here. So this is the ball, right, or the board. If you carefully observe the situation here, if I apply some force of 5 newtons on the board, what happens? 5 newtons on the board, what happens? So a small kind of damage takes place to my hand. Yes or no? Definitely it says. A simple pain will be there for this hand. When I apply 5 newtons force on this, right? When I apply 10 newtons on this board, what happens? The amount of hurt, the amount of pain for me will increase when I apply 10 newtons of force. When I apply 20 newtons of force on this board, so definitely 20 newtons of, when I apply a 20 newtons of force on this, what happens? The pain will also increase for my hand. Yes or no? So definitely it's S. If I apply 50 newtons of force to this board, what happens? The board is very strong, right? If the board is very strong, what happens? When I punch the board with 50 newtons of force, what is happening here? Definitely tomorrow I'll come to you with a band-aid to this hand. Yes or no? So definitely just because as the force acting on the board is increasing and the pain taken by me also increasing. Yes or no? So definitely it is increasing. Look at here, 5 to 50 newtons, the force values are increasing, which I am applying on the board. Alright, so here the pain taken by me is also increasing. At some point of time the hand will break, hand will get a lot of hurt or damage. Right? So here I am applying an action force of 5 newton, 10 newton, 20 newton and 50 newtons. I am applying an action force. Then what is the reason for the damage for this hand? What is the reason to get a pain for this hand? What's the reason behind that? Right? So the reason behind that is the reaction force. What is the reason behind that? Is the reaction force. The reason behind this pain is the reaction force. So carefully listen to me the concept here. The reason behind the pain for me is what? Reaction force. Okay? Clear? So this is the concept of reaction force. So here, how much is the action force I applied? The same amount of the reaction force is also acting on me. I am applying an action force on the board. Board is applying a reaction force on me. If I punch the board with a less amount of force and the less amount of force is acting on me, less pain. If I try to punch it with a more force on the board with the same amount of more force, the board is punching me back. That's the reason I'm getting hurt. Okay, clear? So this is the concept of action and reaction forces. Are you understanding? I hope you're saying yes, right? Let's move on to the Newton's third law of motion only. Okay, here I just wanted to mention 2-3 important statements here, right? So the statement number 1 is action and reaction forces. Action and reaction forces acts on 2 different bodies. Action and reaction forces acts on two different bodies. And most of the people think that action and reaction forces acts on the same body, right? So when we are applying the force on this board, and most of the students feel that or assume that, so everything is for this board only, either on action or reaction force, right? But it's wrong, understand? So, but it's wrong. Because when I punch the board is giving me the punch back. When I throw the ball to the wall is giving a force to the ball to bounce back. Okay, let's take example of this case. Action force is acting on which body? Action force is acting on the wall. The reaction force is acting on the ball. Understand? Action force is acting on the wall, the reaction force is acting on the ball. That's why it is bouncing back. Understand? Action and reaction are not on the same body. Look at here. Action and reaction forces acts on two different bodies. Remember? Okay. And number 2. It's a commonly asked question in 1 mark questions in your board exams. Which force is first, action or reaction? Which force is first, action or reaction? Listen to me carefully. 90% of the students tell that action is first, then only the reaction. Because in our daily life, imagine you have done something to your friend, right? Your friend will be waiting for the right situation and right moment to give you back. Understand? Clear? So here, it will not be the same situation here. When I give a punch of 50 newtons to the board, this board will not wait for the time and the moment to punch me back. Understand? So at the same instant, it is giving me the punch. That's the reason. So I got hurt here. Okay. When I apply 50 newtons of force on this board, so the board will never wait for a next day. So next day, this sir will come, then I can give the punch back. It will not think like that, right? So when I give the 50 newtons force on the board, at the particular instant, at the same instant, what happens? So there is a 50 newton force is acting on my hand here. Clear? That's the reason behind this pain. Understand? So action and reaction forces occurs at the same time. You can say simultaneously action and reaction forces acts. So I'm writing the same here. Action and reaction forces. Action and reaction forces acts simultaneously. Simultaneously it acts. Simultaneously on how many bodies? On one body or two bodies? On two different bodies, right? So these are the two important statements. Even when you finish your studies, when you go for any interview, being a physics student, right? This is the commonly asked questions by the interview board. Right? So in the interview board, the people will be sitting there. As you are a physics student or a science student, the probability of asking the questions from Newton's laws of motion is more. Okay, so be ready, and this is what the basic questions asked. Right? Action and reaction forces act on two different bodies. Action and reaction forces act simultaneously. Right? Same time. So don't think that action is first, then the reaction comes into the picture. Okay, now, and one more important point I just wanted to tell you here. The forces always exert in pairs. Okay, so you cannot see a single force in this case. When there is an action, definitely reaction force will be there. Okay, when there is an action, reaction force must be there. Okay,